Did we just hit the point where aging becomes optional? Like imagine this. You wake up on your birthday. You're 1 year older, same as always. But over that same year, medicine improved so much that your expected lifespan moved forward by more than a year. You spent 12 months, and science handed you back 13. If that keeps happening year after year, you're not chasing a finish line anymore. The finish line is backing away from you. That idea has a name: longevity escape velocity. And it's one of the most dangerous and addictive concepts in modern science, because it feels like a cheat code. Survive long enough and the upgrades keep arriving. Miss a few upgrades and the whole dream collapses. So today, let's do this the honest way. No sci-fi hype, no miracle promises, just the real question underneath all the headlines. What would have to be true for longevity escape velocity to be real? And are we anywhere close? Quick disclaimer before we go further. This is science communication, not medical advice. Don't make health decisions off a YouTube video. Talk to a qualified professional for anything personal. Okay, first, we need to clean up a confusion that makes this topic explode online. When people say living longer, they usually mash 3 different ideas into one, and that's how you get magical thinking. There's living longer on average, meaning fewer people die young. There's maximum lifespan, the record-setting ceiling of how long a human can possibly last. And there's Healthspan, which is the part you actually care about. How many years you stay sharp, mobile, independent, and not stuck in a slow decline. Most of the giant gains in the last century were about the average. Less infant mortality, fewer deaths from infections, cleaner water, antibiotics, vaccines, safer surgery, better heart disease prevention. That's civilization getting better at not losing people early. Longevity. Escape velocity is not that. It's not, the world is safer now. It's a claim about the aging process itself. It's the idea that we might get good enough at repairing the body that the damage from time stops outpacing our ability to fix it. Here's the simplest way to picture it. Aging is like rust. Every day your cells take tiny hits. Some get repaired, some don't. Over decades, those leftovers stack up. Escape velocity would mean your maintenance crew gets better faster than the rust accumulates. Not once, continuously. And that's why this idea feels so seductive. It doesn't require one legendary breakthrough that cures aging. It only requires a steady stream of partial wins that keep buying you time to reach the next partial win. It's basically a survival game where the loot drops have to arrive before your health bar hits 0. But now we have to ask the uncomfortable question: what is aging actually? Aging isn't one thing. It's a pileup of biological problems that interact like a messy group chat where everyone's replying at the same time. DNA gets damaged. The systems that repair DNA don't stay perfect forever. Proteins start misfolding and clumping, and your cells become worse at cleaning up the trash. Inflammation can quietly rise and stay simmering, which sounds small until you realize it's happening every day for decades. Some cells enter a zombie-like state called senescence, where they stop doing their job properly and start secreting signals that make nearby tissue worse. Mitochondria, your cellular batteries, lose efficiency. Epigenetic instructions drift, like the software in your cells slowly getting corrupted. Stem cell pools get depleted, so your ability to rebuild tissue weakens. Then, downstream, you see the big stuff: cardiovascular disease, neurodegeneration, frailty, metabolic dysfunction, cancer risk. That's a key point. What we call aging is the accumulation of many kinds of damage, not a single master switch, which leads to the first realistic version of the future. Longevity probably won't be one magic pill. If it happens, it'll look more like a stack of interventions. Some reduce damage, some repair it, some remove damaged cells, some restore function, some prevent the worst cascades. Think of your body less like a single engine and more like a city. Roads, power lines, water systems, waste disposal, security. You don't cure a city, you maintain it. You fix one system while making sure you didn't break another. But now we hit the part the internet loves to skip because it kills the vibe. Even if the science works in a lab, there's a massive gap between cool paper and safe treatment that changes lives. That gap has bottlenecks, and they're not glamorous. Turning a discovery into a reliable therapy usually takes years, sometimes a decade or more. Regulation is slow because it has to be. When you're messing with core biology, mistakes aren't like a bad software update. Mistakes are people. Then there's measurement. How do you prove you slowed aging in humans without waiting 30 years to see who lives longer? Researchers try to use biological clocks, biomarkers, functional tests, disease risk, and long-term outcomes. But the truth is, aging is hard to measure cleanly. and the field is still arguing about what counts as solid evidence. And then there's access. If the future is only billionaires get the good upgrades, that's not a longevity revolution. That's a luxury product. And finally, side effects. This is the big one. Biology is trade-offs. Push growth and repair too hard, and you might increase cancer risk. Suppress inflammation too much, and you might weaken your immune defenses. Boost certain pathways, and you might mess with metabolism, mood, or cognition. The body is not a simple machine. It's a balancing act. So if you hear someone say, aging is basically solved, the right response is, solved for who, when, and at what cost? Now, with all that realism in place, why are people still taking longevity escape velocity seriously? Because there are genuine reasons this conversation is getting louder. One reason is that in animal models, lifespan and health span can be shifted, sometimes dramatically. It depends on species, intervention, timing, and 1,000 details, but the existence proof matters. It tells us aging is not some untouchable metaphysical curse. It's biology. Biology can be hacked. Another reason is that some aging mechanisms appear across many species. That's important because it suggests there are shared targets. Shared targets are how you build therapies that aren't pure guesswork. And the third reason is historical humility. Humans are terrible at predicting what will be impossible once we truly understand the mechanism. Infectious disease used to be destiny. Cataracts used to mean permanent blindness. A lot of what felt inevitable was really just ununderstood. But here's the question everyone actually wants answered. Have we reached longevity escape velocity? If someone tells you they know for sure, they're selling something. Even if what they're selling is optimism, the honest answer is, we don't know. What we have is a tug-of-war between two worldviews. The optimistic view says the tools are getting better fast. Biotech is scaling. Data is exploding. AI is accelerating discovery. Therapies are becoming more personalized. If we can stack enough smaller wins, the curve might bend, and the maintenance approach could start paying compounding interest. The skeptical view says increasing average lifespan was easier than pushing the maximum ceiling. Humans aren't mice. Human trials take forever. The body's systems are too interconnected. Fixing one thing can break another, and a lot of promising biology doesn't survive contact with real-world humans living real messy lives. My take is the middle. The science is real, and it's moving. But aging becomes optional is still a huge leap from where we are today. Now here's the part that makes longevity escape velocity feel like a thriller. It's not a button you press. It's a timing game. Imagine you're crossing a river by stepping on stones. You don't need the river to disappear. You just need the stones to keep showing up close enough that you can reach the next one before you slip. In this story, each stone is a real improvement. Better cardiovascular prevention, better cancer detection, better therapies for metabolic health, better treatments that preserve muscle, better approaches to brain aging. If the stones appear frequently enough, you keep going. If there's a stretch where the stones are too far apart, you fall. So the big suspense question becomes, are the next couple decades the most dangerous stretch of the river? Are we close enough that staying healthy now could matter massively because it gets you to the next wave of medicine? And this is where the biohacking conversation usually goes off the rails, because people jump straight from future tech to buy this stack. I'm going the opposite direction. If your goal is to make it to the future, the highest impact moves right now are painfully unsexy because they're the basics that keep people alive long enough to benefit from anything new. Sleep. Real sleep, not 5 hours and vibes. Strength training and conditioning, because muscle is not just vanity, it's metabolic health, injury resistance, and long-term independence. Food you can actually sustain, not a 2-week cleanse, with enough protein and fewer ultra-processed calories. Regular medical checkups that handle the boring killers. Blood pressure, cholesterol, blood sugar, apnea, inflammation-related risks, vaccines. Mental health care, because chronic stress and untreated depression can wreck the body quietly. Social connection, because isolation isn't just sad, it's physiologically damaging over time. None of that sounds like live to 150, but it dramatically increases the odds that you're still here and still functional if and when the real breakthroughs arrive. Now, let's talk about why this topic gets spicy fast. Because if longevity upgrades become real, the science won't be the hardest part. Society will. If people live much longer in good health, inequality can blow up. The people who gain extra decades can accumulate more wealth, more influence, more power. Work and retirement get rewritten. A 40-year career already feels long. What happens when you're expected to reinvent yourself for 80 years? Family structure changes when multiple adult generations overlap for a long time. Politics gets weird if leaders and elites stay in charge for extra decades. Identity gets complicated when you're trying to be you after a century of memories, grief, reinventions, and changing culture. And there's the planet-level question. It's not just population. It's consumption, energy, resources, and how civilization organizes itself when the age structure shifts. Plus, there's the personal question no one wants to say out loud. Longer life doesn't automatically mean better life. If we add years without adding meaning, we can end up stretching out anxiety, loneliness, and burnout. So the point can't just be more time. The point has to be better time. So when you hear aging becomes optional, here's the grounded translation. We might make aging more negotiable. We might push the worst decline later. We might compress illness into a shorter period at the end. We might extend health span in a way that feels like getting your life back. That's a big deal, even if it's not immortality, even if it's not 150. And if longevity escape velocity ever becomes real, it probably won't arrive with trumpets. It will arrive as an accumulation of quiet wins, until one day someone does the math and realizes the finish line is drifting backward. That's the real tension. Not are we immortal, but are the upgrades arriving fast enough to keep ahead of the damage? So I'll end where we started. Did we just reach the point where aging becomes optional? Not as a simple switch, not yet. But it's possible we're entering an era where aging becomes more manageable, more treatable, more delayable, and more measurable than any time in human history. And that's still wild. If you want, I'll keep tracking this story with you. What's actually in clinical trials? What's real evidence versus marketing? What's likely to fail? And what might shock us? Subscribe and tell me what you think. Is longevity escape velocity an inevitable future? Or a modern myth dressed up in lab coat language because we're terrified of running out of time?